Hey everybody, thanks for checking in today. I'll start a new chapter today talking about the area of two-dimensional figures. And today we're going to simply start with finding the area of all types of triangles. Okay, so there's probably a formula you know from your earlier days in math for the area of a triangle, which is base times height over 2, or 1/2 base height. Okay, the thing that you need to know about the base and the height is that they must be perpendicular. Okay, so whatever the height is and whatever the base is, they must be perpendicular. They must form a right angle. Okay? Now there's another formula that is only used on equilateral triangles. Okay, you see that down here is root 3 over 4 times s squared. Sometimes I write it like this, s squared root 3 over 4. They mean the same thing. Sometimes it's easier to write it one way or another. Okay, s stands for the length of one side, and since all sides are the same, you can use any of the sides for s. We're also going to talk about the perimeter of a triangle today. How do we find perimeter? Well, simply perimeter is simply the distance around a figure. So to find the perimeter of any shape, in this case a triangle, what you want to do is add all the side lengths together. Okay, the perimeter is simply the distance around a figure, so we add all the side lengths up, and that will give us our perimeter. Okay, and finally, if we are missing the base or height of a right triangle, what formula from a couple chapters ago can we use to find the missing side? That is our good old friend, the Pythagorean theorem, which we will definitely be using today and a lot in this chapter. So that's it. Let's just jump right into some problems here. So example 1 says find the area of the triangle below. So I'm going to go ahead and write down my formula, which is going to be area equals base times height over 2. And as we just talked about in the last slide, we have to remember that the base and the height have to be perpendicular. Okay, so that means we cannot use the two numbers that are given to us here. We cannot use 12 and 20 because those are not perpendicular. What we need to use is 12 and b. Unfortunately, we don't know b. But that's where we just talked about the Pythagorean theorem comes into play. So we can do 12 squared plus b squared equals 20 squared. Doing a little bit of solving on that equation. And taking the square root, we would get b is equal to 16. So these two sides are the sides that are perpendicular. Therefore, those are our base and our height. It doesn't matter which one's the base, which one's the height. Don't get into a habit of thinking the bottom has to be a base, because a lot of times it's not necessarily true. Just know that one of them is the base, one of them is the height. It doesn't matter which one's which. So in this formula, I'm going to put 12 in for the base and 16 in for the height. And that would give us 12 times 16 over 2, which is 96. Okay? But also don't forget units. Units in this chapter are very important. 96 what is the area of the triangle? Okay, there's 96 of what inside this triangle? Okay, the units are given to you. M stands for meters. This is 96 square meters. Okay, that is not read as 96 meters squared. It's read as 96 square meters. Okay. Then what is the perimeter of that triangle below? Well, that's easy enough. We're just going to take our three sides and add them together. And we get 48. And what are the units on that? That's just meters to the first power, or just meters. So perimeter is a distance around, one-dimensional. Area is the inside, it's two-dimensional. That's why meters to the first power for perimeter and meters to the second power for area. Number 2, find the area of the triangle. All right, I'm going to go ahead and write down my formula. And again, the base and the height have to be perpendicular. But oh, look at this right here. Look what we got. It's a right angle. That tells us these two are perpendicular, and that's it. That's your base and your height. Okay? 12 is our base, 8 is our height, and we get 48. Now this problem does not give us units, so we do not need to provide units in our answer. 48 is enough. Number 3, we got to first plot these 3 points. So -4, -6. There's point A. 0, 3 is point B. And C at 5, -6. It's a triangle, so I know I'm going to be using base times height over 2. All right, so what you want to do, if you can, in these problems, is find either a vertical or a horizontal line, and that will be our base. Luckily, we have a horizontal line right there. The distance from A to C, remember this is -4 and this is +5, so the distance would be 4 plus 5, or 9, so our base is 9. So then for our height, I'm just going to draw a perpendicular vertical line, and we can count those spaces as well, and that would also be 9. That's just a coincidence, they're the same. So our area here is 9 times 9 over 2, which is 81 over 2, or 40.5. Again, no units in the problem, so no units in the answer. 40.5 is enough. All right, example 4, is find the area and perimeter of the triangle. We see the 3 tick marks on the triangle sides. That tells us this is an equilateral triangle, so I know I'm going to be using this formula here. Area equals side squared root 3 over 4. All we need is one of the sides. We have it. It's right here, 16. So I'm going to plug that 16 right into my S. All right, if we type 16 squared over 4 in, ignoring the root 3, we get our answer of 64 root 3. That's called an exact answer. However, if we want to round it, we can just type in 64 root 3, and that would give us 110.85. That's called a rounded answer. Okay, so for the first one, we did not type the square root of 3 in our calculator, and the second one we did. The perimeter, since I know all 3 sides are 16, we can just do 3 times 16, and that would give us 48. Okay, number 5. This one tells us the perimeter. So let's draw an equilateral triangle here, whose perimeter is 33. All right, there's 3 sides, so if we do 33 over 3, each side would be 11. Now I can jump right into my formula. Area equals 11 squared root 3 over 4. Eleven squared is 121, so 121 root 3 over 4 is an acceptable answer here because 121 over 4 does not reduce. You can also, if you do want to do 121 over 4, you can write it as 30.25 root 3, but most mathematicians do not enjoy seeing a decimal and a radical in the same answer. Or if you want a completely rounded answer, you can multiply 30.25 times root 3, and that would give us 52.39. Again, there's no units here, so no units in our answers. All these answers are correct. The first one is called an exact answer. So is the second one as well, but again, people don't usually use that form. And then this last one is called a rounded answer. Number 6, if the area of a triangle is 80 and the height is 5, solve for the length of the base. All right, let's start by writing out my formula for a regular triangle here is base times height over 2. Let's put everything in that we know. We know the area is 80. We don't know the base, and we know the height is 5. So we're going to solve for b. I'm going to start here by multiplying both sides by 2 to get rid of the 2 over here. I'm left with 160 equals 5b. And then dividing both sides by 5, I get b is equal to 32. Units are back, okay, because it's just base, it's just the length of a side, it's just one dimensional, so this is 32 inches. Number 7, the area of the triangle is 55 square inches. So again, let's start by writing down our area formula for every triangle. We know that the area is 55 square inches. We know the base is 10. We don't know the height, over 2. So you could do the same we did last time, multiply by 2 and then divide by 10. Or, since we recognize 10 over 2 here is a nice whole number, we could just simplify first. And that would give us 55 equals 5h. And dividing both sides by 5, we get h is 11. And again, our units here are inches. So 11 inches. All right, the last slide is some extra practice. So go ahead and pause the video. Try these 4 problems. Come back and unpause it when you're done. Here are the answers to your last 4 practice problems. That'll do it for the area of triangles. Come back next time. We'll start looking at quadrilaterals.